Okay. We were dealing with the concepts of second module, that is we storage, network technologies and virtualization. See, in that we saw FC-SAN and IP-SAN, and we are dealing with FC-SAN now. We saw the components and also interconnectivity options. You have already studied for your internals, I guess. We have three interconnectivity options: point to point, fiber channel arbitrated loop, and fiber channel switched fabric. See, these are the FC, when you're using FC SAN, these are the connecting options of node or your storage devices. It may be used for anything. See here, I'll just brief the concepts. Here, point is nothing but we use the dedicated links to connect any node. See, node here in your FCSAN node here is nothing but your server or your storage array. These are called as nodes. And here in a point to point, we use a dedicated point to point, that is one to one connectivity, rather than using any middle connection for connecting various devices. We connect node to node, that is server is dedicatedly connected to the storage array, and this is point to point. And when you're coming for FC arbitrary loop, see here in FC arbitrary loop we use the hub. In this is in the figure you can see we use the hub for connecting the devices, where hub will create the loop, shared loop for connecting the nodes, that is your server and the storage. And when you come for FC switched fabric connectivity, which is your third type of in option for connecting, here we use the FC switch, and here we use one or more switches. And when you're using switches, you will be having a dedicated line to the storage array, that is between the nodes, which will pass through these switches, that is inter switch links. Because we are not using a single switch, we use a inter switch links, where one or more switches, two or more switches, so that it becomes a inter switch links. But we see that we have a dedicated line for each node to node connectivity. And here the next thing is your, see, we have seen the switches connecting, that is your inter switch. In this figure you can see that we have a switch called FC switch 1 and 2 here, and this interconnective links can be in the tier format, that is your 2-tier format or your 3-tier format. And here we'll be using this switches in turn will be connected with the FC directory. See, as I told, FC director is nothing but it is used for the interconnecting devices, and it is does the same functionality what the switch will be doing. But one advantage is the performance is very high, the data transmission rate is very high, and also the main advantage is the ports which you can connect to the FC director is more when you compare to the switch. These are the only difference you can see between your FC switch and FC director. See, in 2-tier we are using director. In the first tier we are using FC switches, and in the second tier we are using FC director. See, in this, in 2-tier connectivity, in turn it will be connected to n number of this FC switches. In turn it will be connected to the towards the other side. One end will be connected to the server, and the other end will be connected to the storage devices. And when you come for 3-tier thing, here you can see we have in the first and the third tier we have FC switches, and in turn in the middle we have FC directors with higher ports, so that it has n number of ports for connectivity options. This will give the advantage. And since you are using n number of switches, you have a parallel transmission of data transfer to increase the speed also, we use this three-tier architecture. See here, the interconnectivity links can be two-tier or three-tier, and here two-tier we use one FC director with switches, and in three-tier we'll be using two FC directors for three switches. And this directory and switches will mainly depend on the application. When you want when you are connecting 10 servers with storage devices, you need more switches or directories according to the tier you are using. This is the three tiered structure of fiber channel fabric, switched fabric. And here it is a data transmission. See here he has given for your syllabus, he has given simple example of how the data transmission takes place. See here you have node A, node B, node C, and node D. See, as I told, node is nothing but your server or your storage devices. You can transmit or receive the data. See, in between you have the FC switch. Here we have taken one example of switch here. And as I told you, the switches will have n number of ports which will connect it to the nodes and start the transmission of data. In this way, the transmission of data takes place. You have a dedicated link for transmit and dedicated link for receive, and also receive, transmit. And here one advantage is that you can give a priority. See here, you have bolded arrows towards your node D and node B. This specifies that the high priority is given to node B and node D. See, when you are, for example, when you are transmitting data from node A, then then FC switch will have a request of transmitting or receiving the data from node D. Then automatically it should stop the data or the thing from node A and take up the node D. And when you have parallel things, you can do in parallel. But when node A is working, when you get the transmission for node D and node B, it should go according to the priority. Priority wise, the data transmission should takes place. And this priority things will not deal with more of a logical part. We'll just see in brief how it goes on in SAN. That's it. So this is the overall concepts of this. When FC switched fabric is as, you can give an example in the same explanation. You can write your two-tier and three-tier architecture and also data transmission. And here data transmission, it may come for 5 marks question also. You need to just explain what are the nodes and how ports are connected. You have dedicated links for transmit and receive. It is mentioned in the notes. You can refer it. And next concept is your FC architecture. See, fiber channel architecture. See, as I told, in this module, we'll be using FC SAN and IP SAN for connectivity in common or majorly for transmission in organizations. While using SAN for storage, we use FC SAN and IP SAN. In the first part of this module, we'll be dealing with all the concepts which are included in FC SAN. And here we see today, we'll just see the FC architecture, and in FC architecture you'll be dealing with FC protocol stack, FC addressing. See, today we'll be dealing with FC protocol stack. Here, as we see FC fiber channel architecture, as I told, in fiber channel architecture we'll be dealing with how the stack is. Stack is nothing but you in CN you have a OSI layer where layer wise the data transfer operations will be going on with using a particular protocols. In the same way, FC stack is a same thing where you have a layer wise architecture in which the data transfer takes place, and each layer will have its specific functionality. And also here you can see that fiber channel protocol, that is FCP. Here when you want to use the fiber channel protocols for data transmitting, we usually use the protocol called SCSI, that is serial SCSI. In the last module, we have seen what is SCSI and serial parallel. We have seen all the differences in the last module. Here, this protocol called SCSI will be using, and within the network of fiber channel network, with the dedicated network, will be using the fiber channel network. And also and here, when you're using the fiber channel protocol, you can also connect to the you can also connect external or remote device storage devices, which is attached to the SAN. When you're using FC protocols to run the operation, you can also access the remote or the external devices which is needed. And also you have n number of advantages when you're using a fiber channel protocol. Next we'll see the stack and how it works, then you'll get the idea. See, why we are going for fiber channel protocol is you have n number of protocols for using. Why we are going for fiber channel protocol is that first one is it provides high performance. As I told, when we were seeing the protocols, we have n number of protocols. We saw parallel and also the serial protocols. See, in parallel protocols, we see that the performance is bit lower than the serial, and also the data transfer rate is also bit lower, and hence we go for the serial, that is fiber channel protocol is adopting the serial transmission, so that there will be dedicated link for each transmission, and only at a time one single data bit will be transferred. Hence it provides high performance and also high scalability with long distance capability. That is high scalability in the sense when you want to increase the data storage, or when you want to increase the n number of servers or devices towards both the nodes, there is a scalability, and also with long distance capability. As we see, the connectivity is also depending on the distance. And in the nodes also, we have seen the distances in the previous concept. We saw the distance factor there within the 10 kilometer, how the difference of data transfer and the other things will take place. And the major advantage here is it gives the long distance capability is also assured, and also it supports 15 million devices. It can support 15 million devices for transmission of the data and creating the network using the fiber channel, and also data transfer rate till 8 gigabits per second. Hence, these are some of the advantages you have when you're using fiber channel protocol with the protocol called serial SCSI 3 over your FC network. And also, see, when you're using this fiber channel connectivity for storage, what it happens is for your host or the person who is operating the storage device, which is given to all the SAN devices, will appear that only it is given to one operating system where the host is working. This is also one of the advantage of your fiber channel protocol. And next is your fiber channel protocol stack. See, in this fiber channel architecture, see, when they have asked for fiber channel architecture, you need to explain fiber channel protocol stack and also addressing. We'll see in the next class addressing. We'll see just the protocol stack today. When it is asked for architecture, you need to explain both, and it is 10 marks question. And also there may be chances that you may get each concept for 6 to 7 marks, where stack is asked for 7 marks or 8 marks, and also the addressing. In both the ways the question can be asked. See, in the figure, you can see the fiber channel protocol stack, where it has the layered architecture stack. And here, why this architecture layers is adopted for organizing the structure is because the viewing of the protocols, the communication, because in each layer we will be using n number of protocols. The view of the protocols will be more clear and functionality will be more prominent when you're using independent layer. That is, clear cut image will be given when you're using the layered architecture. And also here you can see we have 5 layers here: FC0 from bottom to top, FC0, FC1. Towards your left side you can see FC0, FC1, 2 and 4. See, here FC3 is also there, but when you are implementing the FC SAN, that is FC architecture, FC3 is not implemented or used because the FC3 functionalities is nowhere usable for the network of fiber channel. Hence, it is hidden and we don't mention in the architecture diagram also. Hence, you have 0 to 4 FC3. In the you can mention, when you are mentioning that the layers, the common communication protocols in FC is in 5 layers from FC 0 to 4. In the braces, you can write that except FC3, which is not implemented, because whatever the functionalities which is there in FC3, it is not useful for the network or fiber channel or the protocols you are using. Hence, we don't implement or we don't use that layer. We directly communicate between the second layer and the fourth layer and the second layer, and we don't communicate through the FC3. And also, when you are seeing the layers, the first at the top you have the application, that is where n number of clients start communicating to the application layer. Application layer will be the source for the clients or the host for connecting. And next comes to your FC4. From top to bottom, we'll see how the functionality works. See, next comes your FC4. And in FC4, you have n number of protocols. That is, all these protocols are used for communication. That is, as I told, this communication, this FC is used for data transferring. All these layers used for communication. That is, it will become an interface between the nodes, that is your server and your data storage. These protocols will help to transfer the data. You have SCSI, which is also a data transfer protocol, and you have HIPPY. HIPPY protocol is also a data transfer protocol. And when you compare to all the protocols, HIPPY has high speed transformation protocol. When it depends on applications you are running on, when you can choose any protocol according to the application. In FC4, we have n number of protocols which are there. According to the applications, you can start working on it. And you have SCON. SCON, you may be knowing the IBM they released this protocol, SCON. And what is the most prominent thing of this SCON is, it is used to connect the computers and the peripheral storage. The same thing, that your computers and peripheral storage, like peripheral storage is nothing but your storage disk, tape, any devices which is used for storage. And also you have ATM protocol. See, ATM protocol, this is used prominently when you are sending the voice, data or video. When you using the multimedia transmissions, this protocol will help you in data transfer, smooth data transfer. And also IP protocols. These are all the protocols which are used for the data transfer, communication of your data transfer. And also this FC4 is called as upper layer protocol. FC4 we call it as upper layer protocol. This is about FC4. And as I told, next is FC3. FC3 functions will not is capable, I mean compatible with the fiber channel, hence we don't use any of the functionalities and it is not implemented in the stack. Next is your FC2. See, FC2 is called as your transport layer. This is you have some bits of things to be borrowed from your OSI layer. The same functionality will work, but this we'll just speak about the stacks here. And here FC2 is your transport layer. And this transport layer, what it includes is the payload. See, payload is nothing but the blocks which contain information to be transmitted. See, payload is nothing but you have n number of frames. You have frames where each framing or blocks which contains what need to be transmitted, the data or the information about the, what need to be transmitted between the nodes is kept in your payload. And also address of your source and destination, and also link which control the information. These are all the things which will be now, I mean which will be there in your FC2. And also what is the function of this I mean FC2 is layer is it helps in addressing and structuring organization of data. Organization will comes to your frames, sequences and exchanging of data. And also it ensures that the flow control and routing, all these functionalities is carried out in your FC2. See here, nowhere we'll go in detail what it is. We'll just mention, we don't see how it does. We'll just see what it does in the syllabus which is included for you. And next protocol, I mean next layer is FC1, and this is called your transmission protocol. See, transmission protocol, this is your transmission protocol layer. And here you can see you have encode and decode. In the figure it has mentioned that encode and decode. And here it includes the transmission protocols which will do the jobs like encoding, decoding, which has the encoding and decoding rules, and special characters which is used, and also your error control. These are all the jobs which is functions which is carried out by your FC1. And also what, and in also what happens is in this particular FC1, the 8-bit character which you are sending, it will be encoded into 10-bit, and also it will be and further when you come across when the data is received or it is transmitted, it will be converted to your proper data which is in the format before. This is one of the functionality of transmission, that is FC1 transmission protocol layer. And next is your last layer, that is FC0. See, FC0 is called as physical interface. Here we call it as physical interface. And here physical interface is nothing but this is the lowest layer of the FCP stack, that is fiber channel protocol stack. And also what this layer does is it defines the interface, media and transmission of raw bits. That is, you know, this physical interface will in turn connect to the transmission, that is where you transmit the data. Hence it has the data of transmission of raw bits, etc. And also it has the FC0 as it also includes the informations like cables, connectors and also other interconnecting devices. It also has the information about it. And also FC transmission can done through your electrical or optical media. Any media is fine with the electrical or optical media. Hence, all this data will be stored and executed by your physical interface. These are all the layers which is included in your fiber channel protocol stack 0 to 4, where 3 is not implemented. Any doubts? Okay. Next concept is your fiber channel addressing. See, fiber channel addressing. See here in this, actually what it does is, we don't actually deal in detail with the concepts.